Hello everybody, this is Mr. Bowman. So today we're going to be looking at the board game problem. You obviously read through it on your own, but a quick overview is you're playing a game where you're going around in a circle, and if you land on someone else's square, you have to owe them tokens or something, more or less the setup for Monopoly way here. So you're going to roll 2 dice, add them up, whatever you roll is what you have to move. If you land on someone else, you owe them tokens. So right now, we are 5 spaces behind this blue player here, and we don't have enough tokens to give him, so if we land there, we lose. But if we land anywhere else, we're good. So what we're trying to do is figure out what is the probability we roll a 5. So there's a couple ways you could approach this. You could actually grab some dice and roll them, I don't know, 30, 40 times, see what you get, get an experimental probability there. My personal preference is to use a theoretical probability, so the actual breakdown. Then I don't have to pull out my dice, which is also good too, because they're at home, so that's not going to do me any good. But anyway, so what I'm going to do here is I'm just going to kind of set up a table and figure out which totals are going to give me 5, and then kind of just do a breakdown like that. So if I make myself a table here, I'm going to have 1, 2, 3, 4, 5, 6. Got distracted by the fact that I'm adding up to 5. 1, 2, 3, 4, 5, 6. Alright, so this one's a little cut off, so apology there. But anyway, so these are all 6s down here. So what I'm going to do is I'm just going to figure out, 1, how many squares I have, and then how many would add up to 5. So my logic here is this is kind of like die 1, and this would be die 2, and then I'll add up the totals to figure out where we get. So this is a 6 by 6 shape, so that's definitely out of 36, right? Whatever I'm going to get. So here, for example, is 1 by 1, which if I roll a 1 and 1, that adds up to 2, so that's not going to work. Here I have 1 and 2, which is not going to work. 1 and 3 is not going to work. 1 and 4 does add up to 5. I'll put a star there. 1 and 5 and 1 and 6 both do not work. So I'm just going to run down quickly, fill out my chart, see how many I have that add up to 5. So I know none of these are going to work, because if I add anything to 6, that's definitely no good. Same logic with 5. 5 plus anything is not going to give me 5 because I can't roll a 0. So then I have 2 plus 1 is 3, 2 plus 2 is 4, 2 plus 3 is 5, so that'll work. And 2 and 4 is 6, so that's not going to work either. So quickly running through here. Okay. So I find out there are 4 combinations that would give me 5. A 1 and 4, a 2 and 3, a 3 and 2, and a 4 and 1. Notice that these are separate, right? 1 and 4 is different than a 4 and a 1. So don't mistakenly think, well, they're the same numbers. Yes, but they're on different dice, which means they're different outcomes. So I have 4 here, so 4 out of 36, which comes out to 1 out of 9, which is 11.1 repeating percent. So I'm going to break that down to 11%. Okay, so my outcome here is I have about 11% or 1 out of 9 chance of rolling a 5 on the next game. So I'm feeling pretty confident that I'm probably going to be okay.